All right, thank you. Let me start. All right, so this time I would, by the way, we still have a bunch of pizza and we don't want to throw it away, so please eat. And you can skip your dinner. All right, so this time I will talk about Git deep dive. This is something I was talking about, I think, in the last year, maybe, but I'm just extending a bit more to tell about how you can understand Git. And for this part, I do the Git deep dive for basic. It sounds weird, right? But what it does mean is I do not explain all the command, but I just explain the basic command you really have to understand. But instead of explaining what this command does, I will explain what this command really does in the background so that we really understand what Git does and we are fully comfortable using it. So how many people are using Git in this room? Oh, everybody. Oh, yeah. Maybe not. Maybe half of you. And have you ever had trouble using Git? Maybe yes, maybe no. So when you are using Git, if it's going well, it's going well. Then when you do the rebase, merge, cherry pick, and when you realize it's something you made some mistake, you try to revert. Then the nightmare starts. So you do not know where you are, and you have no idea how to get it back to the original state. And you have to stand up and go to the friend's sheet and keep saying, oh, by the way, I just tried to reset everything. Could you just delete your Git repository so that you can have the exactly same path as me, right? So today I try to explain what you need to understand. And by understanding this, I'm pretty sure you understand how Git works and how you can make your Git repository back to wherever you want, right? All right, so before starting, Git is just a tool. And when we talk about Git, many people confuse with GitHub. GitHub is a service which understands Git, and Git is a local, the repository, the version control system. And Git consists of the data, which is our source code, and their own tools. So whenever you run in the code, you have to understand that command affect the settings or affect your code, right? And whenever you have doubt, there is a git help command. There are two ways to use git help. You just type git help and add some the command you want to look into. So for example, git help commit. Then you get the help for the commit. And actually it's open up the web page. And another way to find the help is git commit -- help. This is another way you can find exactly the same help. All right, so that's git help. Then you have to understand git config. As the command said, git config is to configure your git. And what kind of the parameter you should configure? First of all, you should configure git username because that's going to the commit, which I will talk about later. And you also need to set the git email address, user email. So you have to set username, user email. And when we're setting the configuration, there are the three places we can set. We call that scope. One scope is the repository local. So let's say if you have two repositories and two projects in a different way, and if you would like to use a different name, project to project, you can set at the project scope, which is a local. And if you'd like to just keep using the exactly same username for the multiple project, you can just set it to global. And there is also another system scope as well. So if you're interested in, just go to git config -- help to see what the scope means. By default, everything went to local. So many documents saying you should do the git config -- global username. The reason why is that because it applies to the entire your PC. All right. And the git init is a very fast thing you need to do. So today I will talk about one project, which is a git demo. Great name, right? And this is, I'm in git demo right now. So if I do the dir, I see nothing, but I am in the git demo folder. All right. So how git works? First of all, I need to do git init to initialize the git. When I do that, there is one folder generated. It's hidden by default. So you need to check the show the hidden folder. Or you can just do the dir command with a A. Yep, and you see .git folder there. Then what inside? This is a very important thing you have to understand, but you don't have to understand everything. And in this topic today, I only explaining what's going to be inside this object folder. So inside Git, we have the object folder, right? So I will explain that. And inside object, we have info and pack. And we also have refs folder inside the .git. And inside the refs folder, we have heads and tags folders. At this moment, nothing in the heads, nothing in the tags. Then finally, we have head file. So what is head file? So let's try to see what's inside. So type. So if you're using Linux, the cat is a command to see this inside file, but the Windows does not have cat. So I use type. So whenever I do type, which you can translate to cat in your Linux, meaning Macintosh. And .git head. And at this moment, it says reference to refs /heads /master. Okay, so it means I should have file called master inside refs heads. Where is that? Is it hidden? No, because I already showing the hidden files, right? So it actually didn't exist yet. But head file, there is some reason, but the header file pointing to the master file, which does not exist yet. All right, so this is a starting point. Then, before going further, we have to understand that there are 3 stages in the Git world. One is working directory. Working directory is something you are working on right now, meaning inside the folder. Then, when we do the tracking the change, we are moving that working directory items, like folder or files, into staging area. Then after that, once staging area is satisfied, we can move in that items into the local repository. And why we have 3 places to working on, there is a good reason why, and I will explain that later. But you just need to understand there is the 3 stages: working directory, staging area, and local repository. All right, so first of all, let me do the git status. And as the command said, it's showing the status of what? It's showing status of the working directory and the staging area. And I have nothing. On branch master, no commits yet, and nothing to commit because I have no files yet, right? So I'm going to my preferred IDE, the Visual Studio Code, and creating the file. So my source, and even though I'm a C# developer, I'm using the text file. Okay. Actually, you can use any type of the file to track the change. So if you would like to track your drawings, you can do that. And inside this file, let me writing something great code. And let me save this. So I created one file, I saved it, right? And let's go back to git status to see what it said. And it said no commit yet, right? Because I didn't commit. But it said untracked files, and I have one untracked file. And when we say untracked, what does it mean? I am not tracking this file. And what do you mean tracking? Tracking meaning I asking the Git to keep eyes on these files. Okay? And if I see the git.git folder and the object, I have nothing yet. I only have info and pack folder, but I have no other folders at this moment. Okay? All right, so next I need to do the git add so that at this moment, my source.txt file is in my working directory. And I want to move into this to the staging area. To do that, I need to issue git add command. So let me do git add And if you are ready enough, you can use this dot, meaning wildcard. You can track everything in this folder, including subfolders. So if I do that, then I added. And how I can prove that running the status command again. Now it says no committed, yes. And change it to be committed, new file, my source.txt. So my source.txt is moving to staging area at this moment. And if I see, by the way, in the Git object folder, there is one folder called 41. Why 41? Because 41 is the right answer all the time. No. 41 is just the first two characters of the hash object code. And I will explain what hash is. And then I have the 1DE48 blah, blah, blah files. And what is this file? And you can guess, right? Because I just added one file. This is a file, right? So let's open this by using the notepad, by hoping it understands what it is. Open by using the notepad. Ooh. It's kind of binary, right? So what I can do, there are a bunch of tools we can use. And one of the tools we can use is Git farming tool. So Git providing a bunch of the basic command like git init, git like add, or git help. In addition to these basic commands, they also providing the plumbing command. What is plumbing meaning? It's a utilities. You can use it when you really need. Because basically, or usually, you don't have to open the file, which is already created inside the .git folder. It's hidden anyway, right? But if you really, really, really want to open the file, you can use one of the command. And guess what? Which command we can use to see the file inside? Of course, cat file, right? We don't have type file because it's coming from the Linux world. So that's cat file. But if I do the git cat file, and which parameter I need to pass. So my first guess is my source dot text. Nope. Nope. So what I can get passing. Here I can pass in the SHA-1, the hash code. So Git basically hashing every object. When I say object, it's meaning file or directory or folder, right? So at this moment, I have only one file. It's already hashed. And how to know the hash number? The hash number is coming from the folder structure. So the first two letters is 41. So I'm passing the -t. I will explain what this -t means. So anyway, 41 and 1DE. And we do not have to pass in all the hash value. We just need to pass enough number so that Git can identify which object is it. And basically, it's kind of 6 to 7 digit, not digit, characters. Right? If I do that, this -t meaning I try to see which type of this object. And it said blob. And Git only has 3 types: blob, which is a file; tree, which is a folder; and commit, which is commit. So this said this file is a blob. So, okay, git cat file. Now I know this is blob, and I know the hash number. There you go, the big red code, right? So my file already inside this git item. Now, if I go back to git status again, status, I see the object in the staging area. But what if I modify the file at this moment? What's going to happen? So let's say later code and save. If I check the file, the timestamp said 8:10 and it's 8:14 now, meaning the Git object is not updated. Maybe creating another item, right, at this point. If I going back to object, no, there is only one folder, one file. So Git did not creating another hash yet. So if I going back to the command, git status, now I see 2 items in a status. Why? Because one file is in the working directory, this one, and another file in the staging area. This is the reason why they are tracking the different way, because every time we are changing some code, we may want to just track it, but we may not be ready to commit yet. All right. So let's imagine my code is done. So I try to git add again. And if I do the git status, now I'm back to one file in the staging area. Now my question is, how many objects already generated? 1, 2, 2, right? So the great part of the Git is once it's creating the hash out of the object, they never delete it. They do eventually, if there is nobody looking at the object, but not as soon as. I think it's 90 days by default. So this 5a should be my new blob object, right? So let's confirm that git cat file, try to find type 5a, what? 5a 117, 117. Yeah, it said it's blob for sure. Okay. And blob 5a 117. And yes, this is my code, right? Now, if I go back to my slide, the third one is git commit, because I'm ready to commit, right? By the way, when I do git commit, where this commit going to? It does not go into GitHub. It's just going to my local repository. What is this local repository? Do I have a database? No, it's just another hash object. And there is a good reason why we call it that other repository. So look at this folder. And I have 2 items, right? 2 folders. And if I do git commit, and by the way, we have to pass in the comment for every commit. This is a good practice because every time you commit, you have to tell why we are committing. And I just say this is a initial commit. Right, the committed. Now, all of a sudden, we have 4 objects. Why? And I really want to know what they are, right? So we already know this 5a guy is the latest blob. And this one guy is kind of old blob, right? So how about this 9d? So if I going back to git cat file type t, dash t, and 9d b989, and we said this is a commit, okay? And how about the other one, e1 something? So if I do the git cat file dash t e1 3ac 6, and this said 3, right? So as I said, there are the 3 types. Commit is a commit, tree meaning it's a folder, and blob is a files. So let's see what commit contains. So git cat file, and I already know this is a commit, and I just using this number. So inside the commit, it has a tree, right? And tree is E1, 3AC. This is exactly same as this one, right? So commit is just another file. It's not super structured, unknown type of something. It's just another file which containing the information about tree with a hash object. Then it also have author of my name. This is why we have to set the git config username. And it also have the timestamp when I committed, right? It's interesting, we have author and we have committer. So author and the committer could be different, right? Anyways, so let's see what we have, what the tree has inside. So git cat file and tree, but this doesn't work. I barely see there is kind of my source text, but it's kind of garbage, right? Why? Because we have a different command. Which command is that? If you have a doubt, going back to the programming commands and try to find something. Commit tree could be ls files. write the else tree. Try to, so working tree, commit tree, read tree, write tree. All right. And I don't know why I cannot find it, but anyways. So there's a command called git ls tree, if I remember it correctly. There you go. So ls tree showing the tree object. And I don't know why cat file cannot do it, but it cannot do it. And I don't want to get bothered because it cannot do it. I need to find another tool, which is ls-tree. The tree has one entry, which is saying blob 5A117. And we already know what this is, right? But just try to double check. Git cat file. This is a blob, and this is my latest code. Now my question is, where this for1 guy is referenced from? No one, because nobody using this file anymore, right? So after 90 days or maybe 30 days, I forget, then there is a garbage collector kicks in and try to see the object which nobody refers to and clean it up. Until then, this is a very important point. Until then, you still have the file. Do not panic. You still have it. Okay, that's the point. All right. Make sense? Okay. Meaning, I do not recommend you guys to keep git add, because every time you do add, it's generating new object. Okay. So try save space. Just do the add whenever you're ready, and just do the commit whenever you're ready. All right. So next one is the git log. So what git log does is git log showing the commit history. So when I do git log, it said commit 9db989. This is actually exactly same as this one, right? Because there is only one commit in my object. And it says author, me, date. So this is another way to look into the commit, right? I will tell you why I'm doing the different way to see the commit, by the way. And it said head is pointing to master. Now we remember that when I do the type .git head, it says lifts heads master. And there were no files. There were no such file in the heads folder, right? So how about now if I do there and git lifts header, and actually we have one file called master, right? Now master is there. My next question is what kind of information inside this master? And you can guess. The answer is it's just containing the no, sorry, I need to type. If I want to see inside, it only has one hash command. So it meaning inside Git folder, there's a file called head, and head is pointing to lifts, headers, and master. And this master is pointing to the commit, right? This is how Git tells me where is my commit, where is my head. I only have one commit at this moment, but if I doing another commit, this will be moving to the another commit so that I can see where is my head. So quite often time when we do the Git stuff, people are talking about head. Your head is not top of the tree. Your head is somewhere else. And this head meaning where this Git, my Git is pointing to, which commit I'm pointing to. Make sense? And by the way, this head, sorry, this master is just a label of the hash. Because as a human being, we do not remember the hash, right? But we can remember the word master, right? All right, so the next step, git hash object. So whenever you are wondering the hash value of the object, you can just manually running the git hash object to generating the hash even before Git doing that. But that's a small command. All right. So branch. What the branch is? The branch is a mechanism that the developer can write in the code parallel. So for example, if I write in the one feature, one feature and another developer writing the another feature, we do not want to mess the exactly same repository, so that we are copying my current status snapshot and give it to the another developer. The another developer working on to the another copy, right? We call that snapshot. And we call that in branch in Git. And how we create, how Git creating snapshot is very different from the legacy system. As I said, legacy system, whenever I create snapshot, it typically basically copy everything, entire folder, entire files. Meaning whenever I create snapshot, it takes time. Just imagine if I have kind of 300 megabyte repository. When I click snapshot, meaning we are copying 300 megabyte, right? If I create another snapshot, it's creating another 300 megabyte. It takes time. All right. So branch, but before doing the branch, let me just create another commit so that we can understand what it is. So I adding new my source to text, and this is second source. All right, and git status. At this moment, obviously, this is the only one file, it's not tracked. So I do git add and git commit, and the comment is add second file. And if I do git log, I have two commits, right? If I look into this commit, git cat file commit, now I have a tree and I have a parent which was not existing before, because git, how commit understand each other is actually child knows parent. Parent do not know about child, right? So the latest commit knowing where it's coming from. But why this is important? This is important when we traverse the tree, because we would like to go back with the previous version, or we want to move forward to the latest version, depending on where you are, right? So if I see this tree, by the way, git ls-tree, and this is a hash. I have two blocks because I already have two items in it, right? The first one is this one, and the second one is this one. By the way, do you remember this hash? This hash was coming from the previous one as well, right? So if I look at the original commit, and if I do git cat file, and I know this is a commit, git cat file, and if I see the tree, git ls-tree, so this blob has a 5A117E, and this blob also has the exactly same hash, meaning whenever I create a new commit, if I did not touch anything for the other object, like the first file, Git does not creating the copy. It's just pointing to the exactly same object. It makes sense, right? That's why Git, many people saying Git just creating a snapshot. It does not copy everything. It just points to the original object. But if we just touching single bit or a byte, it changes the hash. So what does this mean? So for example, if my source code has 10 megabyte size, and if I just adding one dot inside this file, and if I save it, add it, commit it, Git creating another hash object, even though I only changing one dot, right? Then it's creating another 10 megabit file, right? 10 megabyte file, sorry. So Git is not great at tracking the huge file. But usually the source code shouldn't be that big, right? Because now the object-oriented model, the programming model, we should separate each class into the separate files. But what kind of files could be bigger when you look into your C# project? Maybe images, right? video, but we do not change image quite often, right? So you don't have to worry too much about that. But just keep in mind, if you try to version track the very large file, you may not want to use Git from this reason, all right? Now, branch, yes. So when I create branch, I can do the git branch, and I just name it, git branch dev. Do I copy everything? Yes, no. The old system, yes. The git, no. So what git does? If I do this, what git did? This is a question, right? So the answer is, if I go into heads, now we have master and dev. I have two files, right? And let's see what's inside. Type git left head, and just take the master first. Master pointing ed3f63, which is the latest commit. I got ed3f63, right? This is kind of reasonable. Now, if I check div, so it's pointing the exactly same commit. This is why Git branch is very fast to create, because they are just creating one level. Now, master and dev is pointing exactly same commit. It makes sense, right? Because we don't have to copy everything. We're just labeling the commit. So this meaning we can put many labels, as many as we want. We can create master pointing the one commit, dev pointing the same commit, and dev2 pointing the same commit. We can keep adding branch forever, right? And it's very fast because it's only creating one file with a one commit hash code, right? All right. So if I coming back to my slide, so this is a branch. So I started from here and add another commit. By the way, this circle meaning one commit. This I start from this first commit, second commit, third commit, the fourth commit. My master always pointing to the latest commit, as we saw, right? Then if I create branch dev, as soon as I created dev is still pointing to exactly same commit of the master. Make sense? Then if I do git branch -a, meaning try to show me all the branch. Master has special character, meaning I am on the master branch. How you know that? I can switch git checkout dev and git check out what? Then if I do the git branch a, now I'm in the dev branch. But which file containing this information? That's a question, right? That's a question of this session. And you guess which file containing this information. Do you remember? Head, yes. If we see head, it was saying left head master. Now it says left head dev, right? It's easy. So if I coming back to head, I try to open that by using the Notepad again. Why? I like Notepad. And if I say master and save it without using any git command, and if I do the git branch -a, now it said I'm pointing the master, right? So you don't have to do the checkout, but checkout only meaning we are just updating the pointer of the head. All right, so get back to git checkout dev. Now we know what checkout does. We are just updating one file called head. And let me just creating another, or maybe I just want to update this file. So dev1 and git commit am dev1. By the way, this am is a shortcut of the git add and commit. We don't have to do it separate. All right. And if I see git status, nothing. Yep. And let's add another dev2 and git commit am dev2. And if I do git log, and now we have a bunch of log information. So I are using the shortcut git log -- one line. This I said one line, sorry, one line. Now this is what I'm having at this moment. So this is my initial commit, and I did the second commit in the master, right? Then I created branch, and I'm switching to the dev branch, and I'm adding another commit in the dev branch, right? And I also adding another commit in dev branch. So master is still pointing to the old commit. Now, yet the dev is pointing to the latest commit. Make sense, right? All right, so let's keep your eyes on my code. And if I do git checkout master, I am in the master branch. And the file is gone, right? Going back to the original state. What git did? There are several things Git did. First of all, it updating the head file because the head is now pointing to my master. Then, as soon as it did that, it tried to figure out which commit head is actually master is actually pointing to. Now it parsing the commit file. The commit also has the information of the tree. The tree has the information of the blog. That's why Git could reverse all the change back to the original state of this commit, right? Make sense? So if I do the git log one line again, now my head is here. And because my head is here, as I said, the commit only knows its parent. I can parse the parent, but I do not know the child, meaning, which one is that? Yeah, it's overwritten by some reason. So I cannot pass in the child from parent. I can pass the parent from child. Now let me add another code here. Head, no, master, one. And git commit am master one. And if I do the git log one line, now I have 3 commit from the master point of view. And if I want to see all the branch at the same time, I can do -- let me just add graph and O. All right, so this is something you need to understand. So this is the initial commit, and this is a second commit. At this moment, I was adding another branch called dev, and we have different path. The path going straight up, going to the 5EB is my master, right? But dev had a different commit than master, so it's splitting to the right. This mark is going to the right, and we had dev 1 commit and the dev 2 commit. Make sense? So I have 2 branch, and each branch has different commit. Now, what? I need to merge, right? All of us experienced this before. And we need to understand what merge really does. All right, coming back to my slide. All right, so this is a branch, and I did the git branch and git checkout, and we already know what these are. And now we are like this, right? Master has its own commit, and dev has its own commit. And we have to merge it. The question is, do we want merge master to dev, or do we want merge dev to master? This is something some people confusing and make it in a different way. But just be sure, this time I want to bring all the code in the dev branch to master branch. To do that, I have to be on the master. How to check that? Git branch -a to confirm I'm on the master, or if you're geek enough, you can do clear git not type git. Something went wrong. Let me close this one. Goodbye. Let me start from this folder. All right. So type git header. So this is another way to confirm which is my branch. This is a geek way. I'm on the master, so I do git merge. Yes, and I need to specify which branch I want to merge from, right? This time I already have two, right? So in my mind, dev is a kind of clear answer, but git do not know. So I just said dev. Now it said auto merging my source. Yes, sounds good, but the conflict. Why? Because I updating exactly same file, and git do not know how to merge those files, right? So what we can do, git merge tool. The merge tool command is asking git to open the merge tool. And at this moment, I'm setting my Visual Studio 2017 as the merge tool. And you can set any other tool if you want to use it, but I prefer Visual Studio 2017. It's kind of a bit heavy though. All right, it's opening up. And by some reason, it failed. So let me do it again. Git merge tool. And open the merge to Visual Studio. Yep. So on the left-hand side, source coming in, my source is the dev1, dev2, right? This is a dev branch source code. And the right-hand side, this is the master branch source code, and I need to merge it. And how to merge, it depends on you, right? It's up to you. So I just take everything in the one source code, right? Great code, greater code, and dev1, dev2, and another greater code. Actually, I don't need this one. So let's do this. Okay, and save it. Pause it. All right, and git status. So at this moment, I said it's modified my source.txt. This is kind of modified file. Why this is modified? Because I just merging the file, two files into one. So what I need to do, after I stage something, I have to commit, right? This is called merge commit. Some people already heard the word merge commit, and some people do not understand what merge commit means. It means just another commit after the merge. All right. So git commit and merge and dev to master. All right. And if I do git log one line graph all, now you see these two paths happily coming back to original. By the way, this dollar mark, yen, Japanese yen mark, meaning coming back to left. This is going to right. This is coming back to left. Okay, because we do not have the ASCII character to point in the left. That's why they're using the yen mark. All right, so we separated out at this moment with the master and dev. Now, happily, we are back into the one branch. This is how merge works. Makes sense, right? So sometimes people are confusing why they need to commit after the merge. The reason is because we are modifying the file. That's why we have to commit it. All right. Next topic. This is git merge and git reset. Yes. All right, now I found out I made a mistake of this merge, and I need to revert it back. How? There are several ways to revert the change. And one way, if I did not share this information yet, if this is only local to me, I can do the reset. If I already sharing this information to others, I rather should do the revert. What's the difference? So revert meaning we are adding another commit on top of it to reverting the change. For example, if I adding one line, if I want to revert it, I just need to remove the line to get back to the original state, right? But by adding another commit to revert, we do not destroy the commit tree with others, right? Because others already have this tree. If I reset it, I'm losing my tree, and my tree is not identical to others anymore. If I would like to maintain my tree, but yet would like to revert the change, I can do the revert. Makes sense. Okay. Yep. But in this case, I just want to do the reset because nobody having this source tree yet. And where do we want to reset? Maybe I want to go back to here, right? So let me do git reset, and I'm opening my code editor side by side. And reset have several parameters, but I'm using hard here. I will explain what it is. And I'm resetting to this. Now I'm back to original state. Yay! If I see online graph O, this one is gone. I'm back to here, right? And I'm back to here, so head is point to master, right? Where is this commit gone? Did I really delete it? No, right? As a user, we never delete Git object. Git is the one to clean up 30 days later or 90 days later. But at this moment, I still have it. So for example, even though I reset back to my original state, let's say somebody else saying, hey, Ken, what's up? Oh, you just reset? Why? The merge was perfect. All of a sudden, I want to go back to the merging state, right? And if you have no idea what to do, the worst case scenario, you do git merge again, right? But you don't have to because the git still contains the commit. I know the commit number, this one, so I can do the git reset to this hash easily, right? But if I already close the window, and if I'm back into the clear, I do the git log, one line, graph, or where's my hash number of my commit? Anybody remember my hash number? No, nobody remember the hash number, right? That's where the left log command comes in to rescue. Git log only tracking the parent-child tree. On the other hand, git left log tracking all the operation I did. So, quit merge, and I did reset moving to this one, right? Meaning, this is my commit hash right after the merge. I guess at least, right? So let's do it. Copy this hash, git reset hard, and head is now at D49. And am I right or not? Try to see. It's back to the original state. Yay. This is the thing you really have to understand, how Git maintains its information and how you can retrieve the information. All right. Then from here, every command actually doing the very similar stuff. It's just creating another commit. If we do the rebase, by the way, rebase looks like this one. So I did merge before, right? But the reason why I wanted to merge is because I want to take the code in the dev branch into master. But if I would like to keep working on the dev, but if I would like to take these changes after I make the dev branch, what I can do? I can merge this information back to dev. Yes, that's one way, but it may overwriting my changes here, right? If there is a conflict. So what I really want to do is I want to redo the branch and the commit, right? Because eventually what I want to do is like this. I just want to, come on. I just want to do like this, right? Because I just want to do it from the scratch. That's where rebase comes in, rebase, right? And how we can do that. So if I would like to demonstrate that part, what I can do, so this is the master one. So let me just git reset hard, this one. All right, so at this moment, my branch have separate two branches, master and the dev, right? And I want to reface. I want to reface to the latest master, right? So I need to go to git checkout dev because I want to operate on the dev branch, right? Then git reface master. And it does something, and it will also give me some conflict message, so we can do the git merge tool, blah blah. But basically, what it does is just taking the code, try to see if there is any conflict, and if we resolve the conflict, we're creating another commit. On top of it, it keep refacing the commit, right? So let me just do the git merge tool. And Visual Studio 2017 shell comes up. And I just keep it as it is. And git status and git rebase continue. And yeah, I need to do the git commit. Rebase and continue. All right, and try to make sure I have nothing to do anymore. All right, and I need to do the git add. Sorry, git add, git commit. Yes, and git rebase continue. And do we still have something? Never mind. So there is something we need to do the rebase, but the basic idea is Git try to figure out which code we have to bring in from the master to dev and creating another commit so that it looks exactly same as this one, right? But for example, these commit now different from these originally two. Why? Because this commit pointing to this parent, right? But now, after rebasing, this guy is pointing to another commit, meaning that inside of the commit is different, meaning this commit object is a different object, right? So once you do rebase, but what if you would like to go back to the original state? The thing is, Git do not delete the commit before the rebase. So from developer mind, it looks like this, but in reality, it actually looks like this. And these are just kind of hidden, right? Just a hidden. So if I reset back to this commit, all of a sudden, everything back to normal, right? So that's the rebase. And same thing happening to the cherry pick. Cherry pick is, for example, I'm on the master branch, and the dev branch also having, why I'm pointing this one here. I need to point this one. So I'm on the master, and there's a dev branch. But from the master point of view, I just want to get in this code. I don't need the entire branch. I just need to pick up this one only. Then we can do the cherry pick. But the same thing again, we're just creating another commit on top of this one, right? And if I want to go back to the original state, just reset. So the final part is reset the options. So where am I now? So git log online graph all. And to make it simple, let me go back to the very, very fast commit. Git log, not log, reset -- hard. All right. And there is a git status reverse in progress at this moment. All right. Because I don't want to do it, I just try from scratch. By the way, when we start doing the Git, how to delete the tracking information? Easy. just deleting this .git folder. Done. All the Git information is gone. Meaning you should keep that folder, whatever reason, because you would like to revert back to some state in the future, right? But now I just throw it away, everything. So what I can do, I just coming back to the folder again and start from git init and git status and git add, git commit, initial. All right. Then what I do here is I'm adding new file .text and something. So let me just add. And then after that, I'm adding another one. And if I see the git status, obviously I have one in the staging, one in the working directory, and one commit, right? And if I try to go back to the original state, if I see the git log, I only have one commit. I want to go back to this stage, right? This commit. And there are several things I can do. First one, git reset --soft. If I do that, if I check the git status, it does not deleting the staging information as well as working directory information. We are just moving the pointer back to the hash we are pointing to, but we keep the change on both working directory and the staging area. If I do mixed, by the way, this is a default, so if you omit the option, mix is a default. If I do that, if I do the status, now it's removing the staging area information. So if you added something, but if you like to remove everything, but if you want to keep the working directory, this is the one way you can revert back to the original state because it's deleting the added information, the staging area, right? And if you really do not need anything, you can do hard reset. Everything should go on. Because this is untracked, I don't know. Anyways, so that's the difference between soft and the mixed and hard. And do not worry about if you do the hard, yet you need to revert the staged information. Why? Because the object is there, but it's just a bit difficult to track down because object is there, but nobody referencing it, right? So you have to look into the object folder, try to do the git cat file type T, the -T, keep giving the hash file, hash number, try to find the blob, try to see the file, look inside, but you still have that anyways. All right. So that's the cherry pick stuff. All right, so then the revert. Let me do revert quick. All right, so let me just do the commit again. So just saving this one, git add, git commit, and update. If I see my log, I have 2 commits, right? So first one was just AAA, and second one is BBB, right? And let me just add CCC. And let me do git commit AM third update. Now I have 3 commits, and I would like to revert this one. I can do the hard reset, yes, but if I already sharing this tree and I do not want to mess other trees, I can adding another commit. How? Manually, I can delete this one and do the commit again, which revert my file back, right? That's easy. But what if I'm changing so much files, so many changes, which I really cannot track manually? Then the Git does it for you because the Git already know the difference between current commit and the previous commit. They can do the diff these files and write in different the revert stuff. So if I say git revert and I need to point into which one I need to revert back. And what? Update of the resolve conflict. Yeah. So I need to abandon this one first. Let me just close this one and git reset add git reset --add and git log and git revert and could not revert update after resolving the conflict, make the conflict pass git add. Okay. I don't know. Maybe I did something wrong. But the basic idea is if I do the revert, it's creating another commit on top of it to revert all the change back to the original. The reason why I want to keep adding the commit is because I don't want to go back the tree when I already sharing the information to the others. Make sense? All right. So this is how we should revert the change when we publish our source code to the GitHub, because we do not want to mess others, right? And what if others just force submit the change? The revert information is going back to the original, right? So we really want to keep adding the new commit to change it. This is another reason. Well, some Japanese people feel ashamed to making mistakes, so they would like to really delete it. But it's not a good idea once we shared already. We can do the revert. Yes, we can see the history, but making a mistake is not a bad thing. It's a good thing because we can learn from the others, right? All righty. All right, and the stash. I do not have enough time to demo the stash, but the stash is something. So let's say you are working on the master, and you are going to the dev because you want to add a new feature. But all of a sudden, your manager asking you to fix some issue on the master. You have to go back to master, right? But if you just go back to master, what's happening? Your staging information or working directory is coming to the master, which you don't want. So you want to commit on the dev before you coming back to master. But you are in the middle of the development, meaning you don't want to commit it yet, right? So how you can do that? Then but it does not creating the commit information. It's creating the stash information, which having all the information same as commit. After you stash it, your working directory is clean because it's right after commit, right? And you're coming back to master branch and do the fix. After you fix everything, you go back to dev branch and you unstash. Then all the working tree, the working directory information, as well as the staging area information is coming back to the dev branch. So it's more like save, but it really does commit in the background, but it does not treat as a commit because you don't want to commit. So we call that stash. And if you understand that, you are very safely using stash to moving around. But if you do not understand how stash working, it's kind of very difficult to revert it back. All right. So that's the topic I have today. And if you are wondering what other command the Git provide, just go into the git scm.com docs. It has a reference. This reference containing all the command you can refer to. And if you do not know how it works, just try to run it. Or just use the git verb --help to see how it works. But the thing is, help of the Git is not helpful at all. It's very difficult to understand. So I really recommend you to watch YouTube. Go to YouTube, try to put Git and the verb you are interested in. And there should be some video explaining what it is. Or just ping me so that I can tell you what it is. Anyways, now I hope you understand what Git is. So Git is just a bunch of files inside a hidden folder under .git. Right? And now you understand how you go back to your commit. So whenever you made a mistake, do not panic. All the files is still there. the method to retrieve those files exists. Even though you keep make mistake, no worries. We can go back to the original state. If it's before the garbage collector is kicked in, should be 30 days or 90 days. That it's documented where. And we can also change the config to make it like less or longer. Yeah. Anyways, that's it. Thank you. All right. So I stopped the broadcasting, but I accept any question.